question. So it says here, right, in the diagram, EA sports. I mean, in the diagram, EA is a tangent to the curve. Sorry, EA is a tangent to the circle. So there's EA here. It's a tangent to the circle. Okay, fine. Might as well even highlight it a little bit, just for the vibes. I will go back here. Ah, man, come on. There we go. So they said here EA is a tangent to the circle, and then it says here it's ascending to the circle, right? Of which the circle here is A, B, C, D. Now they said here AC is a tangent to the smaller circle, this other one here. It's a tangent to it at C. That's quite interesting. And then it says here CE and AG intersected D. So CE and AG intersected D. You see, so they're just basically describing the sketch. But then what is important is you see here how they have mentioned something like this is a tangent. Already for yourself, you can be thinking of things like the 10 chord theorem, as we said. You see, but the thing is, you don't want to put too many pieces of information. You want to just put what may be relevant. For example, if this is labeled X, right? This is an angle between the tangent and the chord. So if this is X, automatically this is going to be X because of the 10 chord theorem. But what you should never forget also is that in as much as this part here is equal to this part because of the 10 chord theorem, this whole part is also equal to this whole part, also because of the 10 chord theorem. You see, yeah. So things like that, you may not necessarily need to like put them on your sketch immediately, but don't forget them. Reading some more here, they also told us that this is a tangent to this circle here. So if you look at it nicely also, we've said this is equal to this because of the 10 chord theorem. Funny enough, we also have the 10 chord theorem this side of things, you see, because you see here there's an angle here, which is there's a tangent here, there's a chord there. So the angle X over there is also equal to this X over here. You see, this is X, this is also going to be equal to X because of the 10 chord theorem, because there's an angle at the tangent between the tangent and the chord. Now, when you look at this chord, right, this chord is opposite this angle. So here you go. Do you see? Yes. So you see all that we have just identified it based on us reading the question. They spoke of a tangent. But one other thing that you can see they are almost trying to like put in our face is the fact that we have two cyclic quads in this sketch. One of them is for this sketch here. 1, 2, this is a cyclic quadrilateral. And then we also have another cyclic quadrilateral here. There, and there. You see. So as long as there's a cyclic quad, we know there are theorems that deal with cyclic quads. We may end up using them, we may not, but let's see what the first few questions say. So here they said A1 is equal to X, fine. E1 is equal to Y. That's fine. So they said here, for a whole 5 marks. No, so with 5 mark questions, right? Especially with something like Euclidean geometry, 5 mark questions are not like aggressive, What they mean, the thing with Euclidean geometry is with the 5 mark question, you basically are gonna need about like 2 statements and 2 reasons, and then like some kind of a main conclusion. Excuse-moi. Christian Defarai, what the? Yo, sorry, this one was ringing and the call is coming from the number I don't even know. So I'm like, hey, I ain't answering that so late even. But anyways, excuse me. So what am I saying? Yeah, so we're saying we need to prove that the line BCG, there's BCG here. We need to prove that it is parallel to AE. So before we even stress about how to do this, you guys want to think of laws that deal with parallel lines. So the one law that deals with, the one set of law that deals with parallel lines, or the set of laws, is things like, fun, corresponding angles, co-interior alternating. So all you want to do is you want to identify some form of alternating angles here, and we can, based on what we did, fortunately we are finding these are alternating angles and they are equal, because you see here, this angle here, there's a zigzag effect there. There's the angle A1 here, then there's the angle G2 there. So just by analyzing the sketch, we have already answered 11.2.1. This is to also highlight the fact that anytime you're reading a question and you spend a second or two, trying to put stuff onto the sketch, you're not wasting any time. You see, because look, we've banked all that time now, and we're not even going to struggle now, because we just have to connect the dots here to say eventually that this angle is equal to this angle. So for us to eventually show them that this angle is equal to this angle, you can see we just have to do things bit by bit. Firstly, we have to show them that A is equal to C2 because of the 10 chord theorem. You see, A1, which is equal to C2, which makes them equal to X, right? Oh, it doesn't matter. Okay, let's just use the X because it's going to be easier to use. All these are, this is A1, it's equal to C2. So they are both equal to X. The reason there is 10 chord theorem. You see, now that we have known that, now that we know C, yeah.
You see, include equals to X, right? So I didn't include that. Will I still get it wrong?
Nope. It's still 100% fine. If you actually just did this, it's fine, So yeah, if you just did it like that, it's fine. Because now even if we carry on like that, it's still fine. So here we're gonna say C2 is equal to G2. The reason there is also 10 chord theorem. 10 chord theorem. So you see, because C2 is equal to A1 and C2 is equal to G2, it means that therefore A1 is equal to G2. You see, because they are both equal to the same thing. You see, it's a conclusion. So because of our conclusion, we can now say, therefore, BCG is parallel to AE because alternating angles are equal. Alternating angles are equal. You see, we have identified alternating angles that are equal to each other. And then you move on. You see, so that's how Euclidean geometry is assessed. You see, the good news is it's good that the good news is it's good that, yeah, the good news is it's good that you're using the blue book already. You see, because you don't want to spend too long just, swimming in the exercises in the textbook. This is the best way to like properly plan and prepare and study. So with the next question here, 11.2.2, it's saying we should prove with the following, prove the following with the reasons, right? We should prove that AE is a tangent to circle FED. So what's interesting here is, if you look nicely, they're asking you to prove that AE is a tangent to circle FED. So if you look nicely, there's no, in our sketch, FED, there's no circle there. But then what they're trying to say is, if there was a circle there, we should prove that AE would be its tangent. Now, the one way to do that is, it's 99.99% of the time, you're gonna make use of the 10 chord theorem. So meaning all you have to do here is, you have to think to yourself, okay, fine. If the line AE is going to be a tangent to the circle passing through these points here, the line, if what you may call, if a circle is going to be passing through these points, right? For this to be a tangent to that circle, it means that this angle would need to be equal to this one. That's what our job is actually. Our job is to show that F1 is equal to Y. Because as long as we can show that F1 is equal to Y, we would be showing that if there was a circle here, that circle would be passing through these points, and this line would be a tangent to that circle. Because the 10 chord theorem would be something that we would need to be seeing, unfolding. The same way here, we're able to say as long as these are equal, it automatically tells us that these are parallel, because laws complement each other. So in terms of us proving that E1 is equal to Y, remember, you don't want to just do it directly. The same way we wanted to prove that this is equal to this, we didn't just jump to saying these are equal because of something. No, what we did was we found something that they are both equal to. That's how you're going to prove that these are equal. You want to find something equal to F1, and then you want to find something equal to E1. I mean, obviously they're going to be equal to the exact same thing. So our job here is to see, let's see here, what is equal to E1. Fortunately, you see, remember, as long as these are parallel now, we have another set of alternating angles here. E1 is equal to C3. You see, that's something we know in our sketch. E1 is equal to E3 because of alternating angles. So remember, all we're doing is we're trying to find something that is equal to E1 first. So let's see where that will take us. You see, E1 is equal to C3. The reason for that is alternating angles.
Alternating angles.
Yeah.
And GB is parallel to EA.
G what is parallel to what?
GB is parallel to EA.
GB is parallel to EA. Yes. Yeah. Oh, yeah. We can add that there if you want. GB parallel to EAE. That's how we have alternating angles. That's fine. So now we need to see. You see how easy it is for us to say that this is also equal to that. Why are these two equal to each other? Because they are. But then what's the reason that you're seeing here?
Repeat your question.
F1 is equal to C3. But then what's the reason?
F1 equals to C3. Exterior angle
of a cyclic quad. Yes, an exterior angle of a cyclic quad is equal to the opposite interior one. Because you see, F1 is an exterior angle of this blue cyclic quad. That's why F1 is also equal to C3. You see, F1 is equal to C3. The reason is exterior, exterior angle of cyclic quad. Yes, this is an exterior angle of a cyclic quad. Anyways, so you see now, because
if I don't include the cyclic quad part, it's incorrect.
If you just say exterior angle.
Well,
the thing is, it's an exterior angle of what? You see, so you have to include the cyclic quad part, because if you just say exterior angle, it's still a bit too vague, because you're not necessarily showing that you know exactly what you're doing, But then when you say exterior angle of cyclic quad, it's like, oh yeah, it's that theorem. The theorem that states an exterior angle of a cyclic quad is equal to the opposite interior angle.
Okay, so I lost on mark. Okay, cool.
Oh, oopsie. When you say it like that, it's like, okay, that's bad. So you see, they're both equal to C3, so they're equal to each other. You see, therefore, E1 is equal to F1. So you see, we have stated that they're equal to each other. So as long as we've shown that these are equal to each other, then we can say, therefore, AE is a tangent to circle circle what? To circle FED. FED. Now the reason here, you're just gonna say converse of 10 chord theorem. Converse of 10 chord theorem. Like that. And then you will be home free. You get yourself 5 more marks. Wow, 5. That's nice. So the last one here, right? They're asking us to prove that AB is equal to AC. Now, if you look at our sketch, there is AB here, there is AC there. These are two separate lines. If you're going to prove that these lines are equal, you're obviously going to need to make use of properties of an isosceles triangle. If these lines are equal, it means these angles have to be equal too, you know? So that's all we do. If you're going to show that those lines are equal, the one thing to do is to show that these two angles are equal. Now, again, remember, if you're going to show that angles are equal to each other, what you use is an angle that they are both equal to. Fortunately, this big angle here is equal to both of them. One of them is because of alternating angles. The other one is because of 10 chord theorem. You see it, right?
Yes, I see.
Yeah. So we don't have to waste time, looking for something that's there for now. But I think over time, some of these things you'll spot them easily, because all you'll be trying to do is, okay, fine, what's equal to C1? We have alternating angles. And then the moment you find something equal to C1, you then just try to see how this can be equal to that, and then you'll be like, oh, wait, 10 chord theorem. You see, the same way here, we found out that E1 was equal to C3. So all we had to do was to say, okay, why is this equal to that? Because they are, and then we're like, oh, wait, 10 exterior got cyclic quad. So that's the idea, as long as you find one thing, the other will also show itself. So here we're going to say CAE is equal to C1. CAE is equal to C1. So let's see here. CAE is equal to CAE is equal to C1. C1. The reason there is alternating angles. Alternating angles.
Okay.
So with that being said, right, we're going to now say that CAE also is equal to B. CAE is equal to B. CAE is equal to B. The reason is 10 chord theorem. 10 chord theorem. So
Okay.
hence, yeah.
I just checked the answer in the book, right?
Okay.
And does CAE also represent, it's the same thing as A1 plus A2, right?
Yeah. Yes, definitely.
Okay.
Because see, that's A1 here, that's A2 there.
You got
Yeah.
worried.
So here we're
there.
saying these are, yeah. So here we're saying these are equal because sides opposite equal angles. You see, we've shown that they're opposite angles that are equal, so these opposite sides also have to be equal. And we'll get 4 marks. Isn't that lovely? 4 marks. Wait, how is this 4 plus 4 plus 5, 15 now? Oh, maybe that was 11.2. Okay, fine. So yeah, that's how you do these questions here. All nice and dandy without struggling.